Hello everyone, this question has been taken from Irodov Fundamental Equation of Dynamics question number 61. The question is two touching bars 1 and 2 are placed on an inclined plane forming an angle alpha with the horizontal. So these are the two touching bars placed on inclined plane which is making an angle alpha with the horizontal. The masses of the bars are equal to m1 and m2. So this one is having m1 mass, this is m2 mass. And the coefficient of friction between the inclined plane and these bars are equal to K1 and K2. So between 1 and the inclined surface, the coefficient of friction is K1. Between 2 and the inclined surface is K2. And it's given that K1 is greater than K2. Find out the force of interaction of the bars in the process of motion. So what is the force of interaction between 1 and 2? So that is what is to be found out. Second is the minimum value of angle alpha at which the bars start sliding down. Okay, so first we will collect all the data. So in the question given mass of the bar 1 m1, mass of the bar 2 m2, inclined plane angle with the horizontal alpha, coefficient of friction between 1 and the inclined plane surface k1, between bar 2 and inclined surface k2, k1 is greater than k2. And to find out force of interaction between the bars and minimum angle alpha at which the bar starts sliding down. So these are given in the questions, but for convenience we have collected it here. So let us assume that both the bars are sliding down. Since K1 is greater than K2, so therefore number 2 bar will experience the lesser resistance than number 1 bar, and it will tend to move with greater acceleration than bar 1. It means, but bar 1 being moved slowly will push the bar 2 opposite to its direction of motion and will remain in contact with the bar 2 always throughout the motion on the inclined plane. So what does this mean? If it is in contact with each other, so both the bar will move down with the same acceleration, that is W. Since both the bars are moving to the same acceleration, we will take M1 and M2 together as a system. So this system has a mass of M1 plus M2. Because of M1 plus M2 mass, gravitational force in the direction of inclined plane is M1 plus M2 G sine alpha. Okay. So we will apply Newton's law of motion on the system of M1 plus M2. So mass of the system is M1 plus M2. Experiencing the force due to gravity towards the inclined plane is G sine alpha. So M1 plus M2 into G sine alpha. And external force which is acting on M1 is F1, friction force F1, and on M2 is F2. So this is what we got the equation number 1. Now we will make the free body diagram of number 1 bar. So M1 will be experiencing a gravitational force in the direction of inclined plane is M1 G sine alpha. Okay. And along the inclined plane, the other force which is acting on it will be the force due to number 2 on 1. So F12 is that force. F1 will be the friction force acting on M1. Normal to the inclined plane, the component of gravitational force will be M1 G cos alpha. And there is no motion along the perpendicular of the inclined plane. So N1 will be the reaction force. So N1 will be equal to M1 G cos alpha. So you can see here. Now you know that friction force F1 is coefficient of friction into the normal reaction force. So K1 N1. N1 is equal to M1 G cos alpha. So therefore F1 will be M1 G cos alpha. Similarly, we can take on mass 2 in this direction along the perpendicular of the inclined plane, the gravitational force will be M2 into G cos alpha, and that will be counterbalanced by N2. So there is no acceleration in this direction. So N2 will be equal to M2G cos alpha. Therefore, friction force 2 on bar 2 will be K2 into N2. So K2 into M2G cos alpha. So this is equation number 5. Okay, this is what has been written. So you can go through all my write-up, easier for understanding. Now we will apply NLM along the inclined plane, Newton's law of motion along the inclined plane on bar 1. So this is M1G sine alpha plus F12 minus F1 is equal to M1 into W. Okay. So if you see equation 1 and 6, so we will divide equation 1 by 6 and solving we will get this. So F12 will be coming as K1 minus K2 into M1 into M2 into G cos alpha divided by M1 plus M2. So this will be the answer for number A part. Now part B. Since K1 is greater than K2, hence the system to slide, bar 1 must start sliding. If bar 1 will not start sliding, then bar 2 will be not able to slide. So the condition for the sliding should be along the direction of inclined plane towards the downside, the forces should be greater than or equal to the friction force. So M1G sine alpha plus F12 should be greater than or equal to F1. F12 we can put from here, okay, and F1 we can put from here, and solving it we will get tan alpha will be equal to K1 M1 plus K2 M2 divided by M1 plus M2. So tan alpha will always be greater than or equal to this value to enable the system to slide. So therefore the minimum value of alpha will be when the sign will become equal. So tan alpha minimum will be K1 into M1 plus K2 into M2 divided by M1 plus M2. So this will be the condition that alpha minimum can be obtained from this equation. So hopefully there is no issue in understanding. Go through my write-up very carefully and you will get the things clear. Okay, in case of any doubt, please do contact through the message. I will come back to it. Thank you.